Pause here, continue here. So we were looking at a projectile from a cliff at an angle, about as tough as it gets. Not quite as tough as it gets. I'll show you a few that I think are more work, and of those I'll tell you which ones are fair game as a test written question and which ones are fair game as a multiple choice question. Basically, I'm technically going to be finishing off the unit today. All lesson 6 is let's look at weird projectile questions, of which you can expect to see one of these weird ones on your test somewhere along the way, but I don't like surprising you. So it says time to top. Josh, what does it say? Time to what? I think vertical for top. So right away I'm going to relist my data because I've turned the page. I'm going to say AY equals negative 9.8. I'm going to say VY initial. Was VY initial 25? Yeah? And now I have to think. What else do I know? If they're talking about the top, and I know some of you have never been to the top before, but that's okay. VY final is 0. Now, if you had said velocity is 0, I would have said no, because velocity at the top is not 0. It's still moving horizontally. And when you say velocity, I assume you mean adding both the components together, talking about the whole schmear. Certainly, though, VY final is 0. And that's pretty good, because now I can say T equals, I've got 3, I can find the fourth. I'm looking for an equation that has VF, VI, A, and T. And there is. Can you get the T by itself, please?
T equals VF minus VI over A.
VF, nothing, minus VY initial, 25, all over negative 9.8. Couple of nice things I noticed here, Sabrina. I'm going to get a negative on the top and a negative on the bottom. That's good because I kind of want time to be positive. I want a negative divided by a negative. 20. It's going to be negative 25 divided by negative 10. It's going to be really close to 2.5. I'm going to go a little bit bigger than 2.5, so about 2.6 maybe? 2.55. By the way, if you are a nerd like me, and when you're standing in amusement park lines, you try and figure out some of the physics of the rides, and you're doing the math in your head, use 10 instead of negative 9.8. And you'd be amazed what kind of numbers you can come up with, especially if you have a stopwatch. You can time things as they go down. You've got G. You can figure out all sorts of speeds and things. And then when you're on the ride, you can be screaming out, "We're traveling at 33 meters per second." Okay, anyways, I think it's pretty cool. I like to think it adds to the ambiance. We will be doing a Playland physics trip this year, for those who are wondering. It'll be the first or second week of May. Sorry, you know what? I think we will be. I got to double check something. Pause. C. Brendan, can you read C to me? Find the range. Now, I have to point out, and I'd never even thought of this. A student pointed this out last class. They said, Mr. Dueck, this is confusing, because in math, range means vertical. It means how high the graph goes and how low the graph goes. And in physics, range is horizontal. So I'm sorry, but that's the way it is. Think firing range, think shooting range, think archery range, think, oh, a long, narrow, hey, how far down does it go? That's why we call those ranges. So when it says find the range, it's really saying, and now I'm into my horizontal world. I've turned the page, so I'm going to relist my data. If you still have it on the same page, you don't necessarily have to. What the heck was VX? It was 43.301. What if you wanted to be really accurate? Well, your other option, believe it or not, instead of writing that, you could just write 50 cos 30, and you could type that every time, and Shaq, that's accurate to about 99 decimal places on your calculator. I usually don't do that unless I knew I'm doing like a 15 or 16 step question, and this is step 1, and I don't want to round off at all, then I might. But for what it's worth. What did I say it was? 43.301. This is not enough. I only have two things. I need three things to find the fourth. What else do I know? Which time am I going to use? The answer from A or the answer from B? A. By the way, you'll notice also, because we're launching off of a cliff, I can't use the trick of doubling time to the top to get total time. Doesn't work anymore, because you're going to fall for longer than you went up. Looking for an equation that has D, A, V, and T in it. Which equation does have D, A, V, and T in it? Why did I just write that part? Why didn't I bother writing plus a half A, T? Okay, if you're comfortable doing that, I free you up to be lazy and organized that way. On a test, I might write it out and then cross it out just to be uber paranoid and to show the marker, yeah, I didn't forget, I noticed this. Basically, my rule, Rachel, on tests and quizzes, I show everything. In homework, I want you to get good at doing stuff in your head. I'm good with that. So it's going to be 43.301, 6.88. Do that one in your head, Mr. Dueck. Okay. 43 times 6 is going to be 268? I'm a little off. Or maybe I'm way off. I think I forgot to carry a digit. Okay, I forgot to carry a digit. 298. Wow. And units, meters. D. Find the impact velocity. Now, there is an answer that irritates me, because the other way they'll phrase this is they'll say, find the speed that it hits the ground at. And I'll have kids say, oh, 0. No, that's after it hits the ground. Yes, it comes to a stop. So when I say find the speed or find the final velocity that it hits the ground at, I'll usually say find the impact velocity, but not all the homework will. What I mean is the impact right before it hits the ground, what's its velocity? I don't know. But I can draw a picture. If I use my imagination, I think I can I think the impact velocity looks something like that, doesn't it? Because it's coming down slanty off of the cliff. Right? Basically, I'm visualizing that there when it hit the ground. I think it's traveling to the left, and I think it's traveling down at the same time. It's traveling at an angle. It's traveling at a what? Did I say angle? You know what that's a job for, don't you? Ah, see, we're trying to put everything together. So I think now my next step would be, now that I've drawn a little picture, I would say I can break this up into components, where I'll call this one Vx, and I'll call this one Vy final. Why did I put a final on the y but not on the x? In fact, I know the x. It was 43.301. I can already fill that one in. Mickey, what did I write? What do we need? Did you say Vy? That means I'm going to tackle a little bit of this vertically. So over here, I'm going to write Vy initial was 25. I'm going to write Ay was negative 9.8. I'd like to find Vy final, so I'll put a little question mark. What else do I know? I could, don't write this next bit down, I could use D equals negative, what was the height of the cliff? I've forgotten. I could use that, don't write this down, and then I could go Vf squared equals Vi squared plus, you know what, that's a lot of work. I think instead I would use, I know the time of flight is 6.88, because then I can go to an equation, Joe, that has Vf by itself already. I think there is an equation that has VI, VF. Oh, and you've noticed on your formula sheet, it doesn't actually use VF and VI. It uses just plain old V and V naught or V0. I had a British physics teacher, so whenever I see a 0 in his honor, I always call it V naught because that's how he pronounced it. Yeah, I would drop stuff too. It's that revelationary. Okay. Speaking of negative 9.8, right? What? Mark says he thought that was his attractiveness? Okay. Negative 9.8? On a scale of 1 to 10? Negative 9? No? Okay. We're back now? Mark, give me the equation. So it's going to be 25 plus negative 9.8 plus times 6.88. Mark, when we hit the ground, are we traveling upwards or traveling downwards? So am I expecting a positive or a negative answer? So start pre-thinking whether you think the answer should be positive or negative, because that gives you built-in error checks for typos. Again, comment. If you do not want to succeed in this course, don't follow along on your calculator. You want to get in the habit, whenever I pause, quickly get out your calculator, crunch the numbers yourself for 2 reasons. First of all, it speeds you up, which is a godsend on tests if you can, shave off 5 minutes of just typing. But every year, and I know which unit we get to, we do something that's about 10 steps and a very complicated, very big equation. And every year, I have 5 or 6 kids that write everything down right, and they always get the right answer. And Shaq, I know that they were just too lazy to try it in class and figure out how you have to type this into their calculators. So follow along, if you will, please. On that little rant, then, what do you get for VY final? Give it to me to as many sig fig. What do we have? 42? 42.424? Is that right, folks?
Yeah.
Okay. And that I can put on the triangle over here. 42.424. Wait a minute, Mr. Dueck. What, Grayson? Where'd the negative go? Oh, I included it in the picture. Do I not have the arrow pointing down in the picture? I don't need now the negative would be redundant in the picture. Hey, Grayson. It's a right angle. Hey, folks, how can I find the magnitude of V impact? Pythagoras, Math 8, right? And then I can also find the what of what. So let's do the Pythagoras. (43.301 squared plus 42.424 squared equals square root answer. Do you get 60.6? Now, this is a fairly, you got to realize, we've used Vx and Vy, both of which we rounded off a little bit. We've used total time, which we rounded off a little bit. I would probably, Rafi, take anything between 60.5 and 60.7. But if you carry 4 or 5 sig figs the whole way, you will almost always be accurate to 3 sig figs, which is why we say in all of our final answers 2 or 3 sig figs and we're good. But I'll give you some leeway. If you're off by like 0.4 or 0.5, you're rounding off way too much. Carry some extra digits. Of course, that right there is not the impact velocity. It's the impact speed. Let's make it a velocity. Opposite, adjacent. Jordan, which trig function, kiddo? Don't think so. Brandon, tan. So it's going to be, sorry, Jordan, you were zoned out and I picked on you. My bad. Tan theta equals 42.424 over 43.301. Tan theta. By the way, do you notice Vx is 40-something and Vy is 40-something? They're almost the same length. I'll bet you this is going to almost be a 45-degree angle because this is nearly an isosceles triangle. That's not crucial, but I can kind of know ahead of time if I've typed something wrong. If I get an angle of like 62 degrees, I'd be looking at my picture and going, I don't think so. I'm going to guess probably 44, around 44.5 or something like that, because they're nearly the same. Shift tan of opposite over adjacent, and I get, oh, there you go, 44.4. What of what? Well, I guess, Mick, I would live with it if you said south of east, but I would frown. In fact, I'd probably draw the little frowny face, because that is not north and down is not south, because we're looking at the side picture of a projectile. This is not a top view on a map that we've drawn. This is a side view, which means up is not north. I would live with it if you said south of east, but when we're talking about projectiles, we basically say they're either on their way up or they're on their way down. This one, on its way up or on its way down. So we call this below the horizontal. Draw a horizontal line, go 44.4 degrees below the horizontal. That's what angle it's hitting the ground at. Or if it's on its way up still, for some reason, above the horizontal. I would consider this an A- level question. In fact, I probably would not be comfortable asking you this as a huge 7-mark written question. I would be very comfortable, hint, hint, asking you this as a multiple choice question. A tricky one, but multiple choice. Example 11. Cliff at an angle. I like example 11. I like example 11. I like example 11. Example 11 is a nice question. Cliff at an angle. All right. Let's do this one together. Oh, and it wants me to find flight time and then find the range. Okay. How am I going to start? Going to draw a T-diagram. I want a system that I can fall back on. So I'm going to do my little T-diagram. Horizontal, vertical. AX is nothing. AY is negative 9.8. Check. What else? I'm not doing that yet. I know it's there, but I like to go systematically. There's something else screaming out at me to take a certain approach. Eric, do you see an angle? I'm going to go components. To me, and again, I can't call those no-brainers. You need to know your physics to do them. But if you know your physics, to me, you give me something slanty, I'm not dealing with something slanty. Why would I bother? I'll keep it, I'll component. This is nice. So I'm going to go Vx, Vy initial. The only thing I don't like about this is it looks like that 35 is on the vertical line, so I'm even going to go like this, just to really emphasize that I know that that belongs there. I don't want to misread this accidentally. I'm going to label the sides, adjacent, hypotenuse, opposite. Oh yeah, Mr. Dueck, you told us there was kind of a shortcut. There was some way to remember which one was sine. Which one was sine? Oh man, which one was sine? Because I asked you to. Which one was sine? Why? Because I asked you to. Which one was... I'll never get tired of that joke, ever. Sorry. Okay. You know what? Yeah, we noticed the pattern. Vy was your velocity sine the angle. And we noticed Vx was your velocity... Oh, of course it was. Cos the angle. You know what? Well, no, physics, dumb tricks to remember stuff, Zach. And on a test, I would do the whole one fraction equals one fraction, write the sign. Hey, I would do that. But again, am I good with you getting comfortable enough to take some homework in your shortcuts, some shortcuts in your homework? There's a Freudian slip. You say one thing, but you mean another. Yeah, I'm good with you taking shortcuts. Oh, they caught that one too, did they? Okay. Not as dumb as they look. 35 cos. I'll go 32.889. And 35 sine. I'll go 11.971. I'll go to 5 or 6 sig figs, and that should give me enough breathing room so that when I get to 3 sig figs at the end, I'm good. Now, Eric, I'll start to transfer more stuff. So absolutely, I'll move Vx down here, 11.971, and I'll move Vy initial to here. Oh, wait a minute, Mr. Dueck. Copy it down correctly. 32.889. 11.971. By the way, I've seen that happen. That happens on about 1 in every 10 tests. Kids put the vertical velocity where the horizontal column is and vice versa. So don't do that. I wish I had done that mistake on purpose. I didn't, but I think I'm going to do that mistake on purpose from now on the first time to emphasize not to do it. What else do I know?
E.
Which one?
On the vertical.
What is dy? Ah, you said negative. Thank you. Now we have a choice. Well, somewhat. I'm committed to finding time vertically. We can either use d equals vit plus a half at squared and solve that quadratic, and I'm perfectly good. Or we can find vy final using vf squared equals vi squared plus 2ad. And once we know vy final, we can find time using vf equals vi plus at. Who wants to use the quadratic method? Just Mark? No, a few more? Okay. Who wants to use the find vy final method? It's about a tie. For those of you who wish to do the quadratic method, for those of you who wish to do the find vy final method, scribble out the squared. By the way, this is also technically the right-hand equation. It's a quadratic because there's a squared, but there's only a squared term. There's not a linear term, which means you can get the squared term by itself and square root. You'll notice with the distance equation, I can't get the t squared by itself without having a t on the other side. Doesn't do me any good. Where'd the minus 4.9 come from? Half of negative 9.8. I don't have a quadratic solver on my virtual TI, but I do have one on this particular virtual calculator. Polynomial, degree 2, 4.9, 11.971, negative 20, solve. There's a typo there. Isn't it negative 11? It is negative 11, Mr. Dueck. How about you do the quadratic equation right, Mr. Dueck? Mark, did you point that out, or did Sabrina point it out? Who was first? Both you guys get candies. So, if you use the quadratic method, do you get 3.5824? If I keep going here, I'll get 11 point, oh, hey, I have this answer button squared, that's convenient, plus 2 times negative 9.8 times negative 20, square root of that. I get Vy final equals 23.13. I have to recognize that it's on its way down, so I have to insert a negative. Am I wrong? No. It would only cancel out if there wasn't plus anything. Okay? The fact that there's more stuff, this is essentially like a giant bracket, which means you have to do what's inside the brackets first. Good question. So negative 23.137, negative 23.137. And then I can find T by going VF minus VI over A, negative 23.137 minus 11.971 all over negative 9.8. Bracket, negative, hey, answer button, minus 11.971 divided by negative 9.8. And here's hoping I get the same roots both ways. I'm way off. What did I do? Ah, I missed the 1. I got to retype all this. Negative 23.137 minus 11.971, close bracket, divided by negative 9.8. There's the 3.58. I knew I was going to get that eventually. Which one's faster? The one in black if you have a quadratic solver? Honestly, the one in black if you're good with the quadratic formula, even if you don't have a solver. I don't care which method you use. It's kind of 6 of one, half a dozen of the other. Anyways, what did part A want me to find? So I'm going to go like this. A, T equals 3.58 seconds. I'll put a box around it. There's my answer to 2 or 3 sig figs, but I've got one that's a bit longer that I can use to find other stuff too. What did part B want me to find? Oh, that's dx. Well, I know Vx. That was 32.889. I know Ax. And I just figured out time was 3.5824, blah, 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 blah. I'm looking for an equation that has D, V, A, and T in it. Brendan, which one? Go ahead. So I'll go dx equals Vx t. Stop. Why can I say to him in this particular case, stop? A equals 0. If you are comfortable doing that on a test, go ahead. Certainly in your homework, go ahead. So the range is going to be 32.889 times 3.5824. 32.889. 118. meters. Based on this data, was this a human being that threw this? Well, I know that someone with a good arm can throw a football about 60 meters, and you're standing on a cliff, maybe if it was a good aero, like maybe a good baseball or lacrosse ball, fairly aerodynamic and a good mass as well, maybe. But I don't know, that's right around the threshold about how far people can chuck stuff, right? Okay. In your homework, there's going to be a couple of questions where you're asked to find a velocity, and I've done one example of impact velocity, but I haven't done an example of, hey, find the velocity anywhere along its path, if you give me time. I will be doing that in the next lesson, but I'm assigning some questions to see if you can figure it out. If not, I'll be going over it next lesson. I already assigned number 1 and number 2 and number 3. You can also do number 5. You can also do number 7. And number 11.